Hey guys, welcome back to another episode of Simuleos. I'm checking my volume, making sure the camera is set. Let me move it just a little bit to this, that way. Okay, now we're good. Okay, so today's going to be a fantastic day filled with more geometrical optics. I changed the little visualization we had on the side just because our stuff looks a little bit different now. But today, I think we're going to go ahead and move on to the next stuff, which is going to be visualizing a whole bunch of different rays and different ways to watch the rays, basically. So it should be kind of fun. We'll see how far we get. I'm going to open up very quickly by talking about what we're going to do today, and then we're going to go from there. So let's open up Zernal and let's talk about what needs to be done. That was not how you spell Zern. There we go. By the way, the tab autocomplete on my terminal was something that I didn't know about until like 2 or 3 years into using Linux. Holy crap. That, like, I don't know how I lived without tab autocomplete. Anyway, let's go ahead and keep working. I don't know if anyone else had a similar problem where there was something in Linux or Unix or some sort of environment that you'd been using forever and then you just realize there's something that makes your life better. Happens to me with Vim all the time. There's some sort of command in there that I'm like, crap, I should be doing this, but I'm not. Okay, so as you can see, we have a circle. And inside the circle, we have light doing weird things. Now, the idea is that we have some sort of ray of light coming in, and some sort of ray of light coming out at some sort of weird position. Could be anywhere out here. Inside the lens, we have some weird refractive index that causes the light to do some crazy things. Maybe something like this. I don't know. I think a lot of people do Vim. I think it's still one of the most used text editors. At least, I'm pretty sure. Maybe I'm wrong. But anyway, the light comes in and it comes out in some weird way, and we have some sort of crazy thing going on the inside of the lens. Now, what I want to do is try a whole bunch of different schemes, a whole bunch of visualizations today, just to kind of get used to it. And then we're going to move on to the next bit, where instead of sending 10 rays in, we're going to send 1 ray in, and we're going to sweep it down, and then sweep it back up. And this should give us a good idea of all of the different angles that we can see at the end. And then after that, we have to send in basically 10,000 different rays and visualize them all at the same time. Now, to do this, we may, though I'm not sure, I'm pretty sure we might, have to implement some sort of parallelization, but that shouldn't be so bad, right? OpenMP should do a pretty good job of this. So we'll see how far we get. Right now, the slowest thing is not actually the ray drawing, it's the lens drawing, which is what we're currently doing behind the scenes, right? So we're drawing the lens and we're drawing the light going through the lens. So we've got some things that are kind of slowing down, but honestly, at this point, all we're doing is sending light through a lens with a varying refractive index and watching the output. So it's not particularly physically challenging to understand, nor is it algorithmically difficult or anything like that, like the last simulation we were running. It's just kind of simple, fun, and looks good, you know? So if you guys have any opinions or anything that you want to say, any questions, anything at all, let me know. If you guys have formulas that you want to work with for the interior of the lens, if you have ideas on how to make things look better, let me know. Because these are all things that we can fix with time. So let's go ahead and get started, and we'll kind of see how far we need to get. Okay. So, again, if you have any questions, comments, concerns, let me know. I don't intend to spend any longer describing the problem because, again, it's, in my opinion, pretty physically intuitive. And we'll see what we need to do as time goes on. So let's CD into projects, Simuleos, and Geometrical Optics. Okay, so we can do a number of things right now. One of the things that we can do is we can send a whole bunch of rays through. I mean, we can send 100 different rays through. In fact, just as a proof of concept, let's go ahead and go over here. Let's open up the make file. And last time around the make file, I also converted all the images into an animation. However, at this point, I don't want to do that. Instead, what I want to do is I just want to run the make command so you guys get a feeling for how long it takes. So let me just time make. Time. Wait 1 second. Make clean. And then time make. Give it a second to do its thing. It should take, I believe, around 15-20 seconds or something like that. And then once that's done, we're going to run it again with 100 different rays. Oh, that took a lot less time than I was expecting. Oh, let me see something. Let me do Mirage, temp, image, 0000.png, scroll down. Yeah, this is exactly what we expected to see. That looks pretty good. Now, one thing I want to do is change how we do this max alpha guy, right? So let's go ahead. And what do I want to do? Let's go into optics visualization.cpp and let's look for max alpha. Okay, here it is right here. And now let me see. Max alpha is equal to double times 0.5. Let's change this. So let's just do it double times j instead. Is there any other point that I use 0.5? Let me look. Ah, here it is, right there. So let's change this to 1. And let's see what the lens looks like. So let's go ahead and make that. Give it a second to do the drawing. And there's probably a better way to do this. Let's see. Okay, there we are. Let's go ahead and Mirage. Scroll down. I mean, I think that looks better, in my opinion. It's, you know, it's just better. Okay, so now what are we going to do next? What I want to do is send a whole bunch more rays through the system. So let's go ahead and right quit here. Open up Geometrical. Oh, .cpp. And then we're going to, oh, was it in the last one? I bet it's an optics visualization.h or something like that. Yeah. No, it's not here either. Geometrical.h. And there it is. Okay, let's change this to 200. Okay, so the last one took 8 seconds. So if this is going to take 10 times as long, it should take 80 seconds. But I've got a feeling it's only going to take like 30. So let's go ahead and write this, go over here, and let's make it. Actually, let me Control C, and let me time make it. Okay, so I have no idea how long this is going to take, but I don't think it's going to take as long as I expected, or as one might expect. One. When I first got into academia, like, using the phrase one to describe, like, you know, one can do this or one can do that was really, really weird. I don't know if it's weird for any of you guys, but definitely for me, it's not intuitive. I don't, like, naturally say, one can just, I don't know, go swimming today. 30 seconds, that's about what I expected. So let's go ahead and do, look at Mirage. Temp, scroll down. Okay, so here we have all the rays coming in, and they're doing their thing on the outside. I don't think it looks so bad. I mean, we get a good feeling for what's happening. So, how do we want to do this? Let's see, that one took 30 seconds. Can we do 30 seconds? This one should take about 1.5 minutes. So I'm just going to run this. I'm sorry. But we'll see what happens. But yeah, so yesterday, I was, let's see, it was 3 o'clock in the afternoon. No, 4 o'clock in the afternoon. I went back to work afterwards, but I taught some people swim lessons. It's been ages since I taught people swim lessons. Like, when I was in high school and early college, I was actually a lifeguard, so I teach swimming as part of my job, you know? And I really enjoyed it, you know? Swim lessons was one of those things that I could do well, and everyone knew I could do it well, you know? I could teach kids in a 2-week session where they came every day. I could teach them from almost nothing to swimming butterfly, backstroke, breaststroke, and freestyle by the end of the 2 weeks, and I was very happy with that. Anyway, I'm teaching these 2 little girls swim lessons, and it's a lot of fun, you know? I forgot how much fun it was just to get in the water and just kind of, I don't know, mess around for a bit. Get them to go a little bit further than they expected. I don't know. It's kind of cool because you can actually see them pushing themselves and going a little bit further and a little bit further and a little bit further. And there's this one girl, I mean, there's only 2, but one of them, she's really active. She really likes just, you know, doing more than she thought she could do. And it's kind of fun. I don't know. I don't know if anyone else has had the opportunity to teach people like some sort of skill like that, but it's definitely something I enjoy, and I think it's kind of fun. Maybe we should have an OIST skill pill on swimming. That would be interesting. All right, I'm gonna get a quick sip of water, and then we'll continue from there. So, what we need to do what I think we need to do is lower the, obviously lower the line width of each of the individual elements. So we need to lower the, oh crap, how do I put this? We need to, like, thinify, make the lines thinner. There we go. As they're going in, so it's easier to trace them as they're going through. And what else do we need to do? We're doing 2,000 lines, so I don't know how long this is going to take. But again, I've got a feeling it's going to take like another 30 seconds or something like that. Anyway, wait, let me think. The last one took 30 seconds. So the maximum this could take is 30 seconds times 10, which is 300 seconds. So the maximum is going to be 5 minutes. But again, I've got a feeling it's going to be like 2 minutes and 30 seconds or something like that. It's actually weird because the majority of this channel is just people coming in and watching me run things and then like watching them either fail or not fail and then going on to the next thing to run, you know? Like, I don't know if you guys enjoy that or not. Also, feel free to say whatever you want in chat. It's kind of going to be one of those days where we just run things and we wait for it to finish and stuff like that. So if you are interested in just asking a question, any type of question, let me know, because I'm up for talking about just about anything at this particular point in time. Also, yesterday we spent a good bit of time at work trying to figure out how to get this computer set up. For some reason, we just couldn't do it. So it's currently using 3 minutes 40 seconds. That's a little bit longer than I expected, but it's currently running Ubuntu Linux, and man, we just could not get it. So we updated it. And then when we started it again, the GUI was off. And so we couldn't get the GUI up. And if I was running Arch, that wouldn't be a big deal. I'd just, sudo netctl start stuff and we'd be done. But unfortunately, we couldn't figure out how to get netcli or NMCLI, the Network Manager Client, working, which was kind of a pain. So, wait, let me see. Is it loading on my screen? Yeah, so it is on mine. Don't. Good luck. Okay, so let's go ahead and scroll down. Here are 2,000 rays coming in, and there they are coming back out. And honestly, I betcha, if these were, how do I put it? If these were thinner, or maybe they had some sort of alpha value associated with them, I bet you this would look quite good. So let's not make them thinner, and instead add in an alpha value. So what are we going to do? Let's go ahead and write quit. And let me think what we need to do. If anyone else is having trouble with the stream, let me know. I can restart the stream, but again, it is running on my end. Of course, that doesn't say anything because I'm running on the same computer, right? So there could be a number of other reasons why it would be running on my computer and not on someone else's. Again, it's one of those things that I can't really check unless people, like, tell me something's wrong. So let's go ahead and go back to 20 rays, right, and quit. And now let's go into opticsvisualization.h, or better yet, let's go into geometrical.cpp. That was a CA, geometrical.canada, CPP. Let's go. Okay, so let's scroll down here. Geometrical.cpp, 250 lines, seems good to me. Refract, I want to create background, vector lens. No, not background. What do I want? Double max, sphere lens, layer. Where do we initialize everything? Let me go to init. Oh, oops. Init. Here it is. Layer.init. Okay, so let's go to that one. VI optics visualization.cpp. Let's go down to init. Oh, init. Here we are there. And let me see, where do we do Cairo image source surface, Cairo create surface, Cairo background, draw frames, create frame. How about this? Let me go down to propagate in this other guy over here. So let me go to geometrical.cpp. And let's just go to propagate. Now let's go over here, open this up, and go into optics visualization.cpp, and let me look for Cairo set line something. Line cap, line width is what I want. Okay, so now what we're going to do right here at the start is we are going to lower the line width. Now, the line width before I defined as 3, so let's define this one as 1. So we're going to do Cairo set line width of the current frame that we're working with. So it should be frame context. Wait a minute, let me think. Are we working with different frame contexts? I think so. So let's go down here. 1 second. So we're going through all the frames. So let's do it down here. So we're gonna do Cairo, and let me add in some comments. Setting line width to be a little smaller. Okay. Now we're going to say Cairo set line width, and let's do animation dot frame context of frame number, I believe. Then we're going to say 1 instead of 3. Okay, so that would be setting them all to 1. Good. And this is after the drawing of the lens, so this should be okay. Good. So we set the line width. Now, what's the next one? Set font size. Here's what I want to do. Where do I set the color? White. Color. So let me see, white. There, it's there. And it is also, down here. Oh, I should have put it down here. Dagnabbit. Sorry about that, guys. Now let's grab this. Paste it down there. And remove this. Okay, so now what we need to do is in our animate line function, we also need to add in a new, how do I put this? A new variable, a new alpha variable to read in. And this makes it a little bit, how do I put this? A little bit easier to do multiple lines and things like that. So let's do that. So we're going to do alpha here. And in fact, alpha is probably fine. Okay, so let's write and quit, and let's go into vi optics visualization.cpp, and let's go down to the animate line function. Where is it? Animate line, is that not it? Oh, there it is, good. And let's add in double alpha, write and quit, and go into optics visualization.h just to make sure we have it. So again, animate line, here we are there. Go down here, add in double alpha. Okay, write and quit. Now when we go in here, we go down again to animate line. Okay, and when we do Cairo set source RGB, which should be Cairo set source, where is it? Here it is. We're going to do RGBA, and we're going to add in the alpha value. In fact, maybe it's better to do this another way. Let's add in the alpha to color itself. .a, and let's not change the function call. So let's go ahead, write and quit, fix everything that we just kind of broke. So let's see, alpha should be the only time I used it. Yep. Write and quit. And then we need to go into geometrical.cpp, go down to the bottom, and where are we? I need to go to propagate. There we are. And let's change color white here, and let's just change this last one to 0.5. Okay, now what else do I need? Temp, vector, now let's go down here to where we did animate line, and let's remove the alpha from the end. Okay, so now we need to update color, so let's go into vi optics visualization.cpp, which I just realized I have up over here, so let's go ahead and quit this one. Good. And let me clear it because the terminal is kind of messy. Now I need to go into optics visualization.h actually, because that's the one that has the color in it, my bad. So color RGB, and we'll also do alpha. Okay, let me write and quit this, and let me just make it and see what happens. I've got a feeling it'll break. Segmentation fault. Okay, so let me think here. I think the issue is that every time we call color, let's go down here and let me look for color. Here, color for fun. There's one. Is that the only time we call color? So let's go into VI Optics Visualization.cpp. Let's look for color. There. Color map. Color, color. Color, color. Color, lens color. And let's add in a 1 over here. And let me think here. If we have it in there, and we have draw lens, max alpha is going to be, wait, let me think. Double J, draw frames. Where do we do our index plot? Yeah, let's just remove max alpha from index plot. That should kind of help out a good bit. So we're going to remove this, and we're going to say lens color.a is going to be equal to that. Okay. Index plot. And let's go down here and say lens color.a. Good. So now we have to fix index plot, but that's okay. So let's go down to index plot. There's one. Oh, there's a lot of them right there. Create index texture. So let's just remove double alpha, max alpha from each of these. What's up with it, Gustorn? So let me see. Every time I do max alpha, we are going to change this to lens color.a. So let's do lens color A. Next, max alpha, remove this. And then the next one will be lens color.a. Lens color.a. Well, yeah, I thought... Wait. Is that a good thing or a bad thing? Because I was fairly certain that the HTML5 player was better than the Flash one. But maybe I'm wrong. So let's do this. Next, and let's do lens color.a. Does anyone have any strong opinions about that one? .a. Next, lens color.a. Okay. So this then should be set. Okay, now what I need to do, let's go ahead and right quit. Go into Optics Visualization. 1 second, VI Optics Visualization.h. And let me go to where we find max alpha. 1 second, max alpha. There we are. And let's just remove all the max alpha tags from all of these guys. 1 second, max alpha. And down here, max alpha. Right here, make it. It's gonna break. I'm fairly certain because the last one broke. Yeah, so we're getting a segmentation fault, and I'm not sure where. But it's the first time I've seen it. Again, I was fairly certain it was a few months old, but it seems like most people are making a big fuss about it now, so maybe I was wrong about that. But I thought it came out in like December. Okay. So let's see where it's breaking. Let's go up to the top here. We have color. Here. And for some reason, it's a super easy struct, right? So I don't think it should be that big of a deal. So let's see. Segmentation fault. Okay. Oh, okay. Maybe you're right. Okay. So let's see where this guy's breaking. Let's go down to main, which we're already in main. And let's see, create background. Oh, I bet you it's in create background, maybe. So let's check that one out. Create background. VI. Create, Optics Visualization.cpp. And let's go down to create background. Here it is. Let me see. If you run it in GDB, it'll show more where it crashes with a stack trace. That's fine, but I don't remember how to use GDB at all. And I don't like... I keep screwing it up every time I do it on stream. Set source RGB. Okay, that seems fine. Is there something else that I read a color into? Let me do that. Color. Here, color map. Color, color. Color, color. I guess we should have an ampersand there. Next, color lens. Color. I think that should be okay. Let's see, index colors, color lens color. Oh, I guess every time we do those, we should probably have an ampersand. Let's see, color lens color, ampersand. Where's the next one? Color lens color, ampersand. Next, again, another ampersand. Good. So I think that's all we have there. Let's go and right quit, go into Geometrical.cpp, and let's look for color again. Color for fun. Yeah, I will check that in just a second. So let's do, that's the only time I use color? Interesting. There's no way that's the only time I use color. Oh, this is in the wrong file. Okay, let's go to opticsvisualization.h. .cpp, sorry about that. Now let's look for color. Good. Next one, fine. Next one, good. Next one, fine. Lens color, fine. Good, good. Good, good. All those look good to me. Colored background. Okay, let's just go and write this. Go over here. Let's try making it again. Okay. Overloaded animate circle is ambiguous. Candidate for animate circle. Oh, for animate circle. Candidate animate circle frame double vector color. What am I calling? Oh, I see. Let me do that then. Let me go down to animate circle. And let me see. So we don't need this color at the end then. No, yes we do. Wait, what's it saying we need? Void animate circle. See, frame animation. Good. Double time. Double radius. Vector origin. Seems fine. Void animate circle. It's not overloaded. Let me see. Layer 2, time, lens, radius, origin, color. Let me see. Layer 2 is an animation. Double time seems fine. Double radius seems fine. Vector origin, lens.origin should be fine. Lens color. It all looks there to me. Layer 2 is your frame. Time times 0.5 is going to be your double time. Lens.radius. Totally a radius. Lens.origin, lens color. Huh. Yeah, well, I mean, it's telling me that it thinks it's overloaded, so it thinks there's two functions to call. But there's only one. Let me go to animate circle. So here's the call. And there that is. Okay, so let's go ahead and right quit. VI, opticsvisualization.h. Go to animate circle. Here we are there. Vector origin. Oh, I just forgot an ampersand here, I guess. Let me look for other colors. Because I think I fixed all those. Oh, I didn't? Oh, interesting. Okay, so let's do that. Good, next. One second. Color, 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 color. Okay, those all look set. Let's go over here and let's make it again. Okay, so again, it's running into a bit of a problem. Segmentation fault, it says on line 17, which I'm assuming is when it's running geometrical. So that should be okay. So, what is next? Let's go through and let's see where it's breaking. So let's right quit. And what we need to do is compile it. So let me think. ls geometrical.o. For some reason it removes geometrical when it breaks, so let me go into the make file. And let me see. Let's not run geometrical, let's just do this. And let's make that. Okay, now we'll run exactly what customer said, so gdb /geometrical. Then we do, I think it's run, and then backtrace 5. Run. Backtrace 5. Okay, Kairos set line width. Let me see. from user bin, set line width, Cairo, live start main. I gotcha. They're not included anymore. Okay, then Cairo set line width. Let me see. So it doesn't like that call. So let's go into geometrical.cpp. No, I think it's optics visualization. Let me do Cairo set line width. Okay, there's one line width set to 3, and that's the only time that one's called. So let me go here and let's do geometrical.cpp. .cpp. I don't think. I mean, would the optimization flags really be making a big difference here? I feel like they shouldn't. So let me go do Cairo set line width. Here we are here. And let's see what happens if I just remove this line. Let's go ahead, Control D. Yes. Okay. Now let's make that. And let's run /geometrical. Oh. Okay, well this one seems to be running. So then the issue was in the Cairo set line width, which is fine. So I must have just called it wrong. So what do we need to do? Cairo set line width. Did I use this anywhere else? No, I do not. So let me go into objects visualization.cpp and Cairo set line width. Here we are there. It looks to me like it should be a problem. Okay, so let's look again. Oh, sorry about that. Well, let's just take a look at what this made. So let's go into the last mirage, and let's scroll down. Okay, so the lines are definitely, more transparent, which is good. That's kind of what I wanted to see. Okay, now the other thing that is still kind of bothering me is all of these, how do I put it? They have a whole bunch of dots in them. I'm not sure how to get rid of the dots. Oh wait, I think I know how to get rid of the dots, maybe. Let's see, how are we drawing these guys? So let me do, wait, let me think here. Since we're drawing a line from point A to point B, let me see, where are we? And then we're drawing a line from, okay, wait. Where am I drawing these lines? It should be in propagate. So let's go, do I have it here? No, it's optics visualization.h. Right, quit. VI optics visualization, oh, sorry, geometrical.cpp. And let me do propagate. There we are. We are reading in layer 1. Should be okay. Propagate. Okay. So, what do I need to do then? We are drawing, here it is, animate line. Let's see, animation, ray frame, good. Oh, wait a minute. What am I reading it up here? Frame animation. Oh, okay. No, that should be okay. So, if I equals 0, that means we're just saving the initial point. Otherwise, we are, how do I put this? Otherwise, we're doing it not equal to 0. So every 2,000 time steps, we're going to write it out. Now, let me see. Animate line of animation, which is fine. Ray frame, which is the what is ray frame? Start frame. Oh, I see. Okay, so that's where we're starting. Start frame seems fine. Whenever animation.fps, that's going to be how fast we want this to go. Temp p, ray p, and then white. Okay, white is the color that we're using up here, so that should be okay. Ray p is the position that we are currently at. Let me see. Should be correct. Yep. Okay, and then temp p is going to be the position we were at last time, right? So we say temp p is equal to ray.p, so the previous position. So now we're going to be drawing from the previous position to the position we want to go to. And I think one thing that can kind of fix this is by trying this. So let me do optics visualization here, and let me not draw the line cap. Let me see. Before doing any further debugging, could you try moving circle texture creation out of the per frame call? Yes, let me just run this real quick, and then we'll run that while we are doing that. So let me do vi make file, and let's go down here and do that. And then we'll do make. So that's going to take like 30 minutes to do, Gustorn, I think. So let's go ahead and try that then. Okay, so it's going to be an objects visualization.cpp. And what we need to do then is modify a whole bunch of stuff here. So reading in the index texture, right? Let's see, where are we? We are right here. Not using Cairo instead. Is this the one we want? Yes, this is the one with the unsigned characters. So we'll just go ahead and remove all of this stuff, I think, because it's not being used. I mean, it should take 30 minutes for me to do. I need to figure out what we need to do here. Okay, so what do we do here? We do Cairo T, Cairo surface T, image surface create for data. You need to move image and pass it as a parameter. Let me see. Cairo surface T. Let me take a look at this image over here. And let's scroll down. Yeah, so that got rid of the dots. It actually looks pretty dang good now, I think. I kind of like that. Okay, good. So let's take a look at what we need to do then. Cairo context. Cairo surface T image. Cairo image surface create for data. Okay. Cairo surface frame number. Index plot, let me think. Cairo set source surface. Cairo rectangle. One second, I have to think. So Cairo set source surface. Okay, let me see. Cairo rectangle. Where do I call index plot? Let's go here. Up, up, up. Let me see. Index plot there. Here it is. Okay. So this is being called every time step. Okay. Now we go down here. G. Okay. So what we need to do then is modify all the function calls and everything like that. And then we should be okay. So let's go up and I guess let's just do it. So at the end of, let me see, our index plot function here. No, it's out of the end of the texture thing. So we have to create a new texture function is what we need to do. Here, vector double, create index texture. We should have another one for, no we do not. Okay, so what did I do with that then? Oh, we read in the vector double at the end. Yeah, okay. So what we're actually doing here in index plot, right? Wait, what? 1 second, let me think. We are reading an index plot, index character texture. Okay, we're modifying it here. Okay, I see. Then we're reading in max alpha. Okay, so here's what we need to do then. We have everything set. We have the index texture. So now we just have to modify index plot so it reads in the image. So the texture itself, instead of going from there. So here we need to modify this, change this to Cairo surface T image, and then we will fix it from there. So let's do Cairo surface T image, and let's not call it image. Let's call it something. I guess image is okay, but image. I don't know. Okay. So then we have to change it up top. So 1 second, lens, whatever. We'll call it image. Okay, so let's go up to the top then and pull this guy. Yeah, that's what I want. Okay, let's go up here. 1 second, I think it is up here. Good, so lens color, modifying index texture. So let's go down here and let's add these lines in. So animation frame. Is there anything I'm missing here? Frame context, frame number. So this needs to be changed from animation to layer. Okay. Frame context, frame number. Let me see. Do I need that? No, I don't think I do, because I don't think I use CR. Yeah. Okay. Go ahead and remove that. G down here at the bottom. Let's just go ahead and remove these lines here. Okay. Yep, just removed it. Okay, so let's go ahead and go up here. And what's next? What we need to do is color surface T, image surface create for data. Good, so now what we need to do is go down here, and instead of reading in index text to your character, we need to read in image. Okay. And then we go down here. It's okay, Gaston, don't worry about it. And change this to read in image. Okay, so let's write that. Now we have to go into objectsvisualization.h. And let me see, objectsvisualization.h, and we need to go down to the very last index plot and change this to Cairo surface T image. Let's do that. So Cairo surface T image. Write this, go over here, and let's make it to make sure it doesn't break. Seems to be going okay. And we'll take a look at the output at the end. Alright, so let's do Mirage. And, okay. That's not right. Let me see. Why is that not right? 1 second. Yeah, that's not right at all. But it fades in pretty nice. That's cool. Okay, Okay, so that's not right at all. I'll leave this up over here in case someone has some brilliant idea. So let's go ahead and right quit. Update visualization.cp. Let's take a look at this. We're reading in the image. Here I set source surface, image. Vertex X, vertex Y should be okay. Cairo T, animation frame context of frame number. Animation frame context frame number, image, vertex X, vertex Y. Let me see. It looks like it's just stored kind of funny, doesn't it? Like it looks like, Why would sending it through a function modify, it shouldn't modify its contents at all. So let me see. Cut rectangle. You go up here. 1 second. Right here. So, let me see if something like up here could have messed up. Cairo image surface create for data. Index texture.data. Oh, it's probably because this needs to be index texture character. Right, quit. Go over here. Let's try making that. Let me time it this time. And then we'll take a look at that. Okay, took about the same amount of time. Let's go to Mirage temp.png. Yep, okay, that worked. Fantastic. So now we have to figure out this line width problem. I'm liking how this is turning out actually. So let me just try really quickly. Right quit. Let me go into geometrical.h. And let's change this again to 200 like we did before. And let me see if that image looks any better. Right this, go over here. It should take about 30 seconds if you remember from last time. So give it just a second to do its thing. It's currently 5:44 in the morning, so we have plenty of time to do just about everything. It seems a little darker outside than normal. 1 second. Yeah, it's definitely darker outside than normal, but that's okay. Well, I don't know. I mean, so Japan doesn't do daylight savings time, right? And so I can never really get a good grasp on like the time of day based on how bright it is outside. Actually, earlier today it was 8 seconds. I don't know why, but earlier today it was definitely 8 seconds. Okay, here's all the light going in. That looks pretty good actually. If we send in a whole bunch more lines and change the alpha, I think it'll look pretty dang good. So we're getting there, guys. We are totally getting there. Okay, that looks pretty good. Okay. Good. So, let's go over here. Yeah, I'm liking that one. I'm liking that one a good bit. I have no idea, Gustorn. I think for some reason my computer was just running slower yesterday. I'm not sure why. But that's okay. You know, whatever. I'm not judging my computer. My computer is, you know, it's fine. I get tired some days. Okay, so I'm really liking how this one looks. Now what we need to do is keep moving from here. So next thing I need to do is lower the line width. And for some reason that didn't work last time. I'm not sure why. So let's go to geometrical.cpp. Let's go to Cairo set line width, which is right here. Now let me try this again, and let me try setting it to 3, which is what we currently have set. Right, this, go over here, close, and then let's do, make this guy. It's gonna break, I'm fairly certain, and I'm not sure. Oh, that one worked. Oh no, it has segmentation fault. Crap. Okay, so how do we get past this segmentation fault? I don't know why it's currently breaking, because to me this doesn't seem like something it should break on. All we're doing is setting the line width to something else. So let's try doing this another way. Let's remove this, right and quit. Let's go into opticvisualization.cpp, and let's do Cairo set line width here, and change the line width to 1. Right here, go over here, give it a second to do its thing. And I could not imagine this one would break. You know? Like, I really feel like this one will be fine. It's gonna take 25 seconds again, because we're running with 200 lines. But, yeah, we can check the context in a second. Yes. So let's do, Mirage 10. Scroll down. You know what? I think that looks pretty dang good. I like that. Now, obviously, with more lines, it'll look even better. But hey, we are getting there. That looks pretty dang good. I'm liking that. Okay, so now we can do a whole bunch of things with a whole bunch of different lenses. We can just mess around with some things. But hey, let's work on some different visualization now. So for now, I'm going to leave this as is. I actually really like the oh, one second, I'm going the wrong way. I really like the line width of 1 around the lens too. I think this looks pretty good. And let me think, what is the resolution of this image? The resolution of this image is, let me think, 600 by something. Yeah, so if we increase the resolution, yeah, I think this is good. I'm pretty happy with this one. So again, if we add in more lines, it's gonna look great, I'm pretty sure. Good, okay. We're getting there, guys. So what's next? The next thing we need to do is work on other visualization types. So let's do it that way. Right, quit. So we need to write a couple of different propagate functions. Honestly, in my opinion, we're almost already set. There's only one other visualization that we want. Yeah, sure, we can do it with even more lines. But first, what I want to do before I do that is I want to go into geometrical.cpp, and I want to go ahead and do some parallelization, see if that speeds anything up. So let's do include. And forgive me, because I haven't done this in a while. Include, I think it's just OpenMP. OpenMP. I'm going to have to Google this one. Sorry about that, guys. So let's go over here. Let's do OpenMP. Parallel 4. I always forget. I don't know why. So let me see. I just wanted an example really quick. Hands-on introduction to OpenMP. Okay. Abstract OpenMP is not. Just give me. That's not what I want. Oh, maybe that was what I want. That's in Fortran. Dang it. Oh, here it is. Omp.h. 1 second. Omp. Dot h. And then we go down to propagate. I'm just going to try this because I think it'll work just fine. Before we draw all of the rays, I want to put in a pragma omp parallel 4. I think that's what I need. So let's go ahead, write this. Let's see how it breaks. I think I'm already running with an fopenmp flag. Hey, Law Center, what's up? Actually, has it been a while since you've been on stream? I don't think I've seen you for a bit. But if so, or if not, welcome back. How have you been? Okay. So what we're gonna do next, we're gonna see how long this takes to run. I didn't set the number of cores. That won't work with range-based for loops. I think. Well, let's just time it. Wait, I need to set the number of cores. 1 second. Set number of cores. OpenMP. Setting the number of cores, number of threads using OpenMP. Okay. 1 second. Export omnum threads equals, there we go. So let's just do this. Grab this. And let's change this to 8 or something. Okay. So what I'm going to do is I'm going to go over here, run top. And then I'm going to run the following. It's going to be time make clean first. And then time make. Okay. So it looks to me like it's not being parallelized. You're right, Gustorn. It's been great. It's been a while. That's okay. I'm glad you're doing well. And you're right. This does not seem to work for range-based for loops. So what do I need to do then? I need to do this in another way. So let's go here. I'm gonna keep top up. Yeah, I was just about to do that. Good. So let's do it. 4. Int. What am I doing? I equals 0. I less than. What are we gonna do? I think we have raise dot size. And I++. Doesn't matter. So there we go. So now every time we do array, all we need to do is change the way we're calling array. So it's going to be rays of I. So let me go down to each of the rays. There's one ray frame, but that's okay. Ray.p, also okay. Ray.p. So every time we do this, we need to add this character here, rays of I. So where's the next one? Here's that. Add in, oh, shoot, my bad. Oh, darn it. Rays of I. Okay, next. There. Good. So the next one, rays of I. Next, ray of P. Next. Oh, you're right. I could have done that. Okay, yeah, let's, why not? We'll just do that. Okay, whatever. So now we remove all this that I just added in, because I'm an idiot. And then we'll do it from there. Oh, that was not what I meant to delete. Oh my gosh, what am I doing with my life? Okay, 1 second. Next. Raise dot. And I think the next one we didn't do anything with. I keep pressing the wrong button on accident. Sorry about that, guys. Yes, so the rest are set. And then we're in here, and I want to run for auto raise size. So let's do this. Auto ampersand ray equals raise of I. Write this. Go over here, and let's do the same thing we did before. I'm gonna run top. I'll make it bigger so you guys can see it. Oh, maybe a little bit smaller than that. I will put it up here. There we go. And now let's just go ahead, run top, and run time make. It seems to me like it is broken. Okay, so let me see. What did I do wrong? 133. There we are. Change this to ray of P. And now let's pull up top again. Go over here to, oh, shoot, 1 second. Top. Pull up time make. Okay, is it running right? I don't think so. I think it's still not doing what I expected. Yeah, I'm not sure, but this doesn't seem to be running parallel anyway. So let me see. Did I do? Yeah, I said to use 8. Yeah, it's definitely not running parallel. Let's see what happens if we open up Mirage. Looks exactly the same, which is good. It looks really cool. But it's not what I wanted. Okay, so let me see. Pragma on parallel 4. I would have thought this would have worked. Why wouldn't it have worked? What am I doing wrong here? So Pragma on parallel 4. Let me see something. So adding parallelization to for loop. Open MP. My Google foo is great here. C++. It opens up a link that I already had open. Fantastic. Okay, so let's go down here. Pragma on parallel private. Ooh. No, I want on parallel 4. So parallel 4. What? Oh, is that not a thing? Let's do parallel 4. Oh, it's super misty outside. Parallel versus parallel 4. So, I don't think there's any difference. One is shortcut to the other. Pragma on parallel spawns other group threads, where Pragma on 4 divides loop iterations between spawned threads. So let me see. Pragma on parallel 4 directive. Okay, so let's see what we got here. Pragma on parallel 4 is exactly what I have down here. Let me just check the makefile. Okay, so we should have an fopenmp. We do. Just checked. Oh wait, maybe we don't. Maybe this one doesn't. So let's check. fopenmp. There it is. Oh, okay. So in our new group, we don't have it. My bad, guys. So std C++11. This would totally explain some issues. fopenmp. Right, quit. Now let's pull up top one more time, and let's run make clean. And now let's run time make. Give this a second to do its thing, and yep. Okay, let's go into the make file one more time, and let's see what we got here. So let's remove this one, add time make. Yeah, okay, so it's totally breaking. Let me see. Cairo pattern destroy assertion Cairo atomic int get. What? Pattern 0. Let me see. Maybe there's a way. OpenMP in Cairo. Program multi-core processors. Inkjet goes through C++ code conversion. Pixel map. OpenMP lists. Let me see. Program for multi-core processors. Oh, Cairo University, that's not what I want. Apparent failure of parallel for loops. Maybe this is it. So let me see. I see no problem with the code you posted, but we'll just code backward do. Let me see. That's parallel modification check by Cairo. You could try adding a simple spin lock. I don't actually know how to do that, so that'll be fun. So let me see. Spin lock. Let me see. That's not exactly what I wanted. Okay. So let me think. Spin lock, maybe to OpenMP. How OpenMP spin lock time be controlled. How to use lock in OpenMP. Okay, so I guess, we need like some sort of sync threads guy, right? So that should do it. But I don't know how to do that. So let me see. Let me go back down here. Let me take a look at the image that we have right now. So let me scroll down really quick. Yeah, I think honestly all we need to do is add a bunch more lines, which is why I wanted to do the parallelization. Because if this takes 25 seconds and we add another 10 times that many lines, it should take, at least according to what we ran last time, 5-10 minutes, which is longer than I like to run things on stream. I did do it earlier on stream though, so don't tell anyone. Again, guys, if you have any questions, comments, concerns, let me know and I'll totally talk about those as soon as we see them, or as I see them in chat. Okay, so I know for GPU computing, in order to get this to run, all we need to do is probably run a, how do I put this, like a sync threads command or something like that before animate line right here. So let me think. How do we do that with OpenMP? Okay. Gusfrun suggesting a spin lock, and I don't know what that is. So, So how do we do it then? Define code backwards. Input stumped 4. Let's see. Prime below is incomplete. Maybe they put a solution here. Let me see. I think it's straightforward. The J loop iterations are independent as the code stands. Try this. Oh, what if I do the following? What if instead of no, that should be okay. Animate line. That's not an issue. So let's go here. Let me clear. Let me just try making it one more time. Okay, so it's saying Cairo fix path, Cairo fix drop line 2 assertion, Cairo path last OP, Cairo OP line 2 failed. Maybe this is a standard error that people come across? Let's see. Doing the old Google search, no. Okay, so what do we need to do next? We don't need the parallelization in here. Obviously it runs fine without the parallelization. It's just, come on, I've got enough space on my computer. I'd love to do parallelization. Because that should speed things up, I would think. Well, it speeds the drawing up, right? Which currently is not the thing that's taking a lot of time, but it could be, you know? So let's see. Yeah, I'll leave it out for now, and we'll come back to this. Gustron maybe has a very cool solution, but right now I don't. So let's go ahead and remove this for now. And let's keep going. So, what we need to do next is we need to draw... Oh. Okay, well, never mind. Gustron says he... Okay, let's do it. Pragma, critical, Cairo stuff. Too late. I'm already trying it. Pragma, critical. 1 second, down here at the end. Is there a capital A? What happens if we press capital A? Holy crap, this whole time. I just learned a new Vim thing. Okay, but he says to wait, so I'm currently waiting. But seriously, guys, I hope you guys are doing great. Let me know if you guys have any questions or anything like that as to what we're doing. Anything like that's definitely not off the table. You're in Raj. So again, what we need to do next is we basically need to take a single line and run it all the way down here, and then all the way back, so we can see all of these rays being created. Okay, let me take a look. Open link. Let's see what we got. So we have class spin lock. Oh, so it looks like, what do we have here? Class spin lock. Atomic flag locked, atomic flag in it. I don't actually know what atomic is. Void lock. While locked, test and set. Okay, let me run this version here. Write this, go over here, Control D, and let's make this. See if it runs. It says we have an issue. I expected an end of line before. Oh, maybe we don't need this. Maybe because it's... I don't know, let me see, make. Okay, well it seemed to be okay with that. I guess it's going. Okay, the last one took 25 seconds. Let me run top. Is it using all the cores? It doesn't look like it is. It looks like it's just dawdling along. I guess that's okay. Yeah, I don't think it's doing much at all right now. So let's go ahead and close this one. Let's Control C. And let's see. So you want this to be on a new line, you said? Something like this. You critical section all the rest of the... My bad. Okay, so let's see what this does. Okay, wait, let me run top again. Is it currently using a whole bunch of threads? It is not. Dang. Okay. So again, I actually have 12 threads to work off of, but I only wanted to run 8 for the stream. But let me see. Geometrical.o. Okay. So let's see, what else can we do here? Let's go ahead and I'm gonna Control C out of this. Open up this terminal. Good. So let's see what we need to do. Pragma omp critical. 1 second. Pragma omp critical. Okay. Critical directive. Omp critical name block. Omp critical. Try the spin-lock version? Sure. I don't know what atomic is though in C++. So it'd be void propagate spin lock lock. Then we do lock lock unlock. Okay. Yeah, we can try it. So is atomic? Let me look it up real quick. Atomic C++. And let me see. Atomic operations. What is this? Each instance. What is atomic? Is atomic just another parallelization tool? Let me see. Okay, well, I'm going to assume it's another parallelization tool of some sort. Where was it? It was over here. So I guess we can just go ahead and try this real quick. So let's grab this. Let's go over here and go into right quit, vi geometrical.h. And let's add it in, I don't know, somewhere in here. So we'll do, maybe up here. Atomic is a way to make memory operations atomically indivisible. Atomically. See, the thing is, atomically to me means something differently than what it means, I think, to everyone else. So atomically to me means atoms. And I'm kind of... Who came up with the naming convention? Okay, so class spinlock. Good. Let's go ahead and take a look. Is this what we want? And let me add this in here. So, spinlock class 4. What do I want it for? Parallelization. Okay, let me go up here. Let me do a very quick. Do I put it after this? 1 second. Vi optics visualization.h. Yes. Very quick. Vi geometrical.h. Let's go down here and let's do include. Include atomic. I think that's what I needed. Yes, good. Right, quit. Go into geometrical.cpp. Good. No, I think everything else already added in. So let me see. Propagate. Here we are. So what we need to do is at the very start of propagate, we need to add in the lock. So we're going to do the following. Spin lock. For whatever. What do I call it? Spin lock lock. Lock. Good. Now we go down here, and I think right after the parallel 4, good. We do lock and unlock for Cairo stuff. So let's try it. So we. Where are we? We are here. I'm critical. Go ahead and DD there. Oh, it just finished running. Let's go ahead and run that. Go down here. There, and then we want to do lock.lock, I think. Yep. Lock.lock. And then lock.unlock at the end. Lock.unlock. Okay, let's see what happens. Right, go over here, make. Is it currently doing anything? Oh, let me run top. Okay, there we go. Look at that. Everything seems to be running full thing. Well, it seems to be more stuff running. But it doesn't seem to be running any faster. In fact, it seems to be running kind of crap. Let me see. Yeah, it certainly doesn't seem to be running any faster. So let me quit this real quick. And let me time this and see how long it takes. I was expecting it to be like much faster because it was 25 seconds before. That's what it was before. So let's take a look at how long it takes this time. But it certainly seems like everything's running, right? I mean, look at that. All the cores, it's not just one core going. It looks like most of the cores are going. Yeah, which means it might not be any faster, right? Maybe just because of the way Cairo does it, we can't really make it any faster, which is kind of a pain. But that's how it goes. Since the draw operation is more expensive and you're forced to do those sequentially. Yeah. Let's just see how long it takes. We might be able to pull some strings to do some parallel drawing, but quite frankly, I'm not so interested in that. I'm okay with, oh, this will be slower? Well, let's just see how long it takes. Give it some time to do its thing. Yeah, okay, so I don't know if it's foggy outside, or if my window's just full of, like, it's cloudy. Those 100% utilization are literally spinning on the spin lock. Ah. Darn, that's unfortunate. So, let's, Let me just see if we can wait just a little bit longer to have it finish. I just want to see how much slower it is, just out of curiosity. Nothing more than that. Again, guys, if you guys have further comments, or you want to, or you have any ideas as to what, as to things that we could run, let me know. Totally interested in that. Today actually might be the last day that we're doing the geometrical optics. Actually, maybe we'll do it again tomorrow. But I think after today, we'll have the visualization pretty much complete, and then it's just a matter of basically just replotting it and getting a whole bunch of good images for a video to make on it. In fact, I could probably get this video up next weekend without too much trouble. I just have to work on some stuff tonight, do the video audio this afternoon, and then we're set. You know, I think it's just gonna be a fun video. You know, nothing spectacular, just a cool video talking about geometrical optics. Okay, this is, I'm gonna call it, guys. I'm gonna have to call it. Control C. Real time, 2 minutes 31 seconds. Much slower. So, oh, did not mean to do that one. So let's go ahead and close here. Yes. Yeah. Okay. So we will go ahead and remove the lock stuff, DD, DD. Remove the parallel stuff up here, DD there, and remove the lock stuff at the start of this guy. Okay, let's go to the start here, and let's go ahead and, it should be fine. Let me write this, make sure it runs, time make. Then let's go ahead and remove all those warnings. Let me see, diff, we'll probably need diff actually. But we can do the sign compare, so let's go to 120. Raise.size, size t. Write that. Okay, give it a second to run. It should be done pretty soon. I thought, yeah, 22 seconds. That's okay. And what did we make, just for the record? Mirage. Scroll down. Yeah, look at that. Okay. The things you're parallelizing are not worth it. They just a few vector multiplications. Yes, however, when we get into having, like, here. Here's what I'm going to do. I'm going to go over here, right quit, go into geometrical.h, change this number to 2000 actually. This will take, according to the last run, about 3 minutes to run. And while it's running, I'm going to add in a new function for what we're going to do next. So again, what I want to do next is have a single ray sweep down and sweep back up. That's all I want it to do. So we have a maximum line, or a maximum, how do we put this? We basically know where we're sweeping through, and we just need to run it a couple times. The drawing will always be significantly more expensive. Yeah. Yeah, you're probably right. Okay, so what are we going to do next? Let's do... let's make it. And I'm going to time it to see how long it takes. GTA 6 confirmed? Cool. So let me go here, and let me run the last... what am I doing? I don't know what I'm doing. Let's just make it. Okay, we're getting a whole bunch of warnings, but that's perfectly okay. Now let's go into... No, I don't want to do that. Let's go into geometrical dot H. And let me do, I think, oh, yeah, no, this is fine. Let me go down to propagate, and let's add propagate sweep. So we're gonna say, wait, why do I have a template here? Double step size, double max felt. Why is this a template? I'm not exactly sure, but that's okay. I'll keep the template. So let me do. Template is so that it can accept any lens type. Oh, yeah. Okay, that's fair enough. Yeah. Wait, what? This stream has no delay? How's that possible? Part of the Illuminati? You're the only one that has no delay. No delay. Everyone else has, like, delay. Yeah, I remember. It just took me a second. So, here's what I'm gonna do. Propagate function for a single ray. Sweeping across lens. Okay, so now we're gonna do template. I need to learn templates better anyway. Type name. T. Good. Now we do void. Propagate. Sweep. And we're gonna do, what do I need? So I don't need to read in array. That's not what I need. So let's see, we need constant lens T. Constant, you know what I meant to say. T. Ampersand lens. There we go. And again, just so people can read this a little bit better, because I always have trouble reading templates, the idea is that we have a constant type. That type is T, and T is something that we don't know. That's why we have a template for it. Risa 401. You can open Twitch video stats. It shows the delay to the broadcaster. I didn't even know you could do that. Thanks, Gusterun. 1 second, I'm fixing my sleeve. Okay, so constant T lens. What else do we need? We need step size. What is step size? I think we need step size, so double step size. Okay, double max velocity. Sure, let's read that one in too. Double, 2 minutes 24 seconds, not so bad. Double max velocity. And what else do we need? We need frame animation. Let's add this down here. Because there's going to be one more thing that we need, but I don't remember what it is right now, so we'll come back to that. Animation. Okay, let's put this, go over here, and now let's take a look at the image. I'm kind of interested to see what this looks like. So let's scroll down. Here's all the light coming in. Okay, so honestly, this wouldn't look so bad. I think this would look great if we had a different alpha value to work with. 7 seconds isn't so bad. Well, that's pretty good. Okay. So honestly, I think this would look great if we just had a different alpha value set for our lines. I think this is pretty dang good. I'm quite happy with this. So we have all the light coming in, hitting the lens, and then doing this. Yeah, I think that's pretty cool. Let me try a different lens type. I'm really liking this, guys. I really like this. Okay. That's like the best delay ever. Maybe. I think someone's had better. I don't know where you live, Risa. Maybe you live in Japan. Maybe that's good. Yeah, the runtime's not bad. Again, it's because the time that when we only had 10 rays, most of the time was spent in drawing the lens texture, right? So it was done drawing this guy right here, right? So now most of it's not spent there. What I want to do what I want to try now, since it's only going to take a few minutes to run and we know that, is I want to go ahead and right quit, go into geometrical.cpp. Oh, then I don't know, Risa. But that's pretty cool, I think. So I want to go to refractive index at, that's not what I want. Is it what I want? Double lens radius. Wait a minute. I don't know. Let's go down here to the bottom. Oh, this is the formula for the invisible lens. I was just getting kind of confused here. So let's see, diff R. I don't need that. So let's go here. There. Comment this guy out over here. Let's try the invisible lens out, see what happens. Now let's right and quit. Go over here and let's time make. It might break. No, seems good to me. Okay, so now we're gonna do, let's see what happens. So let's go into geometrical.h one more time over here, and let's grab this function that we just made. Oh, I guess I need to grab the template too. So let's go ahead and right quit. Via geometrical.cpp. And let's go down to the propagate function. There's one, there's the other. And let's put this template directly under this propagate function. So it should be right about here. There we go, put it here. And let's go from there. I don't think the invisible lens will look as great with a lot of rays. I don't know, I just want to see. Honestly, gosh darn it, 1 second. Somehow, I don't know what I just did, but I tipped over my water and it was like rolling under my bed, and my bed's like super small, so if I don't get it, it's really hard to get my bottle. Anyway, what was I gonna say? Yeah, I don't know what it's gonna look like. It might look better, it might look worse, I don't know, it might look like complete crap. No idea. Okay, so let's keep working on this function. So it's gonna be very similar to what we had before, right? So let's go here. And let's just, honestly, for now, let's just copy what we currently have for propagate, and then let's fix it up. So we're gonna take this, go down here, copy that, and we're gonna go from there. So let's go ahead and paste it. We go down to temp p equals ray p. Temp p equals, ooh, 1 second, let me think. There we go. Okay, so we now have to copy this right here. Good. Now let's go down here, and let's put it down. Don't copy around propagate? Why not? I think this should be okay. Okay, so let's see. What do we need to remove? A lot of things, actually. Okay, we want the color to remain the same. Size Ti raise.size. Yeah, so we're gonna have to remove this entire loop. And then we'll go from there. Good. You should what? You should make separate lenses and pass it to propagate? Let me think. Yep. Okay, so that means I have to modify propagate a good bit in order to do that. Okay, so let me think. Okay. So I guess, yeah, we might be able to try that. We can try that. Let's go ahead and get rid of this. Okay, let's think about this another way then. Let's write and quit. Go into geometrical.h, down at the bottom, remove this guy. Write and quit, go into geometrical.cpp. Okay, so we currently have propagate. Okay. So let's create a couple new functions then. No, I'm not trying to vary the refractive index at all. What I want to do is I want to have a line start here, move down here, and then move back up. A single line. I don't want the refractive index on the inside of the lens to change. Don't want that to change at all. Just want a light to start here, go down, and then go back up. This means somewhat heavy modifications to our propagate function, though, if I want to do this. So let me think. Not that heavy. The only thing that we need to change is down here. When we do, let me think, for size T. No, you're good. Let me think, because there's definitely a way to do it this way too. Let me think. So we have size T, raise.size, so that's going through all the different rays. So we could read in a vector that has only one element every time. Let me see. Absolute value, lens origin 5, size T, time resolution. What is time resolution? I less than time resolution. What is time resolution? Let me check. Time resolution. There it is there. Next. It's only defined there. Let's write and quit. Oh, I know what time resolution is. Good, we're set. Wait a minute. No, I don't. Time resolution must be the final time that we're working with. You could output a different ray at every frame. Yeah, that's exactly what I want to do. I'm just trying to think of how to do that. Oh, yeah, maybe you're right. That one took 5 minutes and 31 seconds. Let's take a look at what it looks like. Here's light coming in. Yeah, you're right. This one's harder to see. Much harder to see. And it also broke with that many rays. So that didn't look nearly as good. But we can make a Pac-Man type of a game out of it. Waka waka. No, that didn't quite work out. But that's okay. You know, the trick is finding what works for the different lenses and stuff like that. So let's go ahead and quit here. Let me try one more. Geometrical.cpp. What do I want to try this time? Let's go ahead and get rid of this guy. DD. Open up a new line here. Comment this out. Comment that out. Let me try one more. So let's do, that's 1 over r. Let me just try error function of r. Yeah, let's see what happens here. Write this, go over here, and let's make that. Okay, so now, let's get this propagate function working. So, what do I need to do then? Let me take a look at this function right here, and let's see what we need to do. So we're going through each individual time step, right? And we are creating an array for that time step, I think. So let me just see what we're doing. We're setting the line to be a little smaller. That's okay. In fact, that is not what we're doing anymore. So let's go ahead and remove that line. Okay. Now we see temp p is equal to array.p. We don't say that anymore. We remove that line. So let's see. Absolute value of ray px greater than lens origin x plus 5 times lens.radius plus 1. Continue. Good. Now we do ray.p plus equals... Wait, what is this if statement saying? If absolute value of ray px greater than lens origin x plus 5 times lens radius plus 1. Oh, okay, this is cutting off excess. Here we're going. So cutting off excess calculations. That was not how you spell calculations. Past 5 times lens.radius. Okay. Now, what do we say here? Ray position is equal to ray velocity plus step size. Okay, so what we're doing here is we're actually going through and we are simulating the ray itself. So we're going through and we're saying, okay, we're every time step we're going through. Iterate over all the time steps first. Yeah, that's exactly right. That's what we need to do. Have a variable ray index that increments every frame. Only simulates ray index. Have a variable ray index. Wait a minute. Maybe I'm misunderstanding. Here's how you do it. Iterate over all the time steps first. Good. I have a variable ray index that increments after every frame. Yep. And only simulate rays of ray index. Yeah. Yeah. Okay. So let me go here. Let me do Mirage Temp. Scroll down a little bit. Whoosh. That one just went straight up. Can't help with that one. Okay. So let's go back to the one that we had before. Brain quit. Let me go into, oh, there was one really cool one that you sent me the other day. So here's Simuleos. Let me go to GitHub here. Let me go to my account. Can I go to my account? Let me just go to github.com. 1 second. github.com. What do I want? I want to go to Simuleos here. And then I want to go to issues. View refraction index. There's one that I liked. Let me try square root of length p. Is that the one? Yeah, let me try square root of length p. Oh, no, like a few days ago. You know, we just ran this a few days ago. So let me try square root of length p. What is p going to be? Let's go here. Square root of length of... It's just length of p. What is p? I don't remember what p is. Oh, position, obviously. What do I want here? Position. Okay, so let's do that. F absolute value of r, diff cutoff lens p. Oh, we already have p. Okay, let's just go ahead and write this and see what happens. Right here, and make. Okay, so now what am I going to do? I'm just going to add in the function again. So let me go into geometrical.h. That was right, down here at the bottom. Add in a new template, similar to what we had before. So we're going to say function. Well, let's just paste it. Let's go here, function. Wow, 1 second. Template / function for sweeping a single ray across the lens. Let me see. Open link. Void sweep, ray index 0, simulate rays. For I equals 0, I listen time steps, I plus plus. Yep. Simulate rays I, ray index plus plus. Draw rays I. Let me think. Ray index plus plus. I think this is doing, it's pretty close. Yeah, this is pretty much what I want. So let's see. I want propagate sweep. Or I guess we could call it, propagate sweep, fine. Okay. It's okay, don't worry about it. Let's see, ray array rays. We don't need that one, but I think we do need everything else. Step size, max velocity, everything else should be there. 5. Ray index. Yeah, that's fine. Okay. So, let's do this. I think everything else should be fine. I think we have everything else we need. Right quit. Wait. Grab it first and then right quit. Geometrical.cvp. Now let's go down to propagate. Propagate. Oh, I'm always so hungry at this time of day. So let's scroll down to the bottom. Here. And let's paste it. Okay. Add in some curly brackets. And I guess let's get started. So, what we need to do is first go through. First, we need to simulate the ray itself. Oh, wait a minute. Let me think here. So we're gonna have to do 2 loops. Yeah, 2 loops. Draw rays, ray index. Yep, that's exactly what we need. So let me see. We will simulate a single ray. And then what do we want? We want to simulate it a certain number of times. And change the position each time. Oh, sure, whatever. So we're gonna say for int I equals 0, I less than, how do we want to do this? I guess we have a number of frames, right? We could just do as many frames as we have available. So we definitely will. That's in the simulate rays right here. Right? So you do int ray index equals 0, right? I less than time steps, I plus plus, right? Then we do simulate rays, draw rays, ray index plus plus. Here, let me just get it written and then we'll see what's up. Because actually, I'm not fully sure. 1 second, let me think. Maybe I'm misunderstanding what you wanted to do here. Yeah, so we're simulating, we're doing a single ray. We have to go through and we have to basically, so we have to calculate where the ray's going, right? So if the ray's doing something like this, we have to calculate where the ray's going. So that's going to be the interior loop, doing all the calculations there. And then the exterior loop is going to be drawing one, and then drawing another, and then drawing another, then drawing another. So we need like 2,000 on the exterior and like whatever, how many time steps we have on the interior, right? So we draw one, and then, so we create the array for one, the vector for one. We draw that, create the vector for another one, draw that one, create the vector for another one, draw that one. And we keep doing it that way, right? I mean, maybe there's a more intuitive way to do this. I could do it with a 2-dimensional array or something like that. But this is the only way I'm currently seeing how to do it. So Let me think. So we should have like a number of rays that we're going to be simulating here. Let me think. Actually, you might be right. Let me think. We might be able to... Wait. We might be able to... Yeah, if we give it all the same time step... Yeah, you're right. We don't need the vector. Yeah. Okay, so let's go through and let's read in an additional variable, which is number of rays. So let's go here, num rays. Then we're going to do plus plus I. Okay, and you're right, we don't need the additional vector. So let's go here and let's do constant length t. And then let's do int num rays. Oh, that was meant to be a comma. Right quit. Into geometrical.h down to the bottom, and let's do the same thing here. So it's going to be int num rays. Okay, now let's go into geometrical.cpp down to propagate. Sweet. Good. Now what do we want to do? We're going to go through all the different rays. Seems fine to me. Now, what do we need to do? Like Guster said, we don't need an extra vector. All we need to do is draw it out every time. So the interior loop, what we need here. Yeah, that's what we need to do. We need to draw a ray per frame. So now we need to draw the ray. I totally agree. So let's do drawing a single ray. Okay. So first thing we need to do is define initial position for ray. Okay, so the initial position is going to be but you don't need num rays equals num rays equals... Wait, you don't need num rays? Num rays equals number of frames. Yeah, let me see. VI, optics, visualization.cpp. Yeah, we should. It should be .h, and it will be, yeah, num frames, you're right. Okay, so let's fix that up. Propagate. Sweep. And let's see. You're right. We can probably do it that way. Good. I quit optics geometrical.h. Down at the bottom. And what do I want to do? Propagate sweep. Right quit. Geometrical.cpp. And let's do propagate. Sweep. Okay, and we want to do num rays, so we want num frames. Minus 50. Okay, so now we're going to go here, and we're going to take a look at the last image. I don't remember what I ran, so let's see what it looks like. Oh, this is the one that just constantly goes in towards the center. That's, it's interesting, but maybe not what I meant to do there. Okay. So, let's see. Now we have to define the initial position for the ray. So, let's see. What do we want to do here? Thanks, that your fan. Oh, wait. Never mind. Hey, that your fan. What's up? Thanks for coming in. Okay, so what do we have? Num frames minus 50. Num frames is actually a global variable at this point. Sorry about that. It shouldn't be. It should be in our frame struct, but I was kind of being stupid when I made it. I can fix it later. It's definitely something that should be fixed. I don't know. I wasn't thinking about it at the time. Okay, so we have to define the initial position for the ray. Now, what we want to do actually is num frames. Let me think. Yeah, sorry about that. Again, I usually say no to global variables, but for some reason, I don't know what I was thinking. Okay, so let's go down here. And what do I want to do? Num frames divided by minus 50. So what we need to do is the following. I guess we can just sweep all the way down. Just one sweep down, and then I can reverse it in Blender. So what do I need to do then? We're going through each of these guys. Now we have to go through all the different time frames. So, or all the different time steps. And I think this is also a global variable known as, time resolution. That's what I thought. For size t, I equals 0, I less than time resolution, I plus plus. And then we'll go from there. I have too many global variables. My apologies, guys. So for int I, I think size ti, I equals 0. Then we do I less than time resolution, plus plus I. Go down. So here's how we're going through and simulating each individual guy. And then we basically just need to go forward and basically do the same simulation we did before in the propagate function. It's just in this case, we need to draw the ray out in a different way. So we're inside here, and let's just go ahead and grab what we need from the propagate function. So, yeah, I don't know, I was kind of not, I was doing things quickly. Okay, else if, so I think all we need is this guy up here. Here. Yep, that's what we need. Okay, so let's go down here and let's print it out. There we go. Okay. Cutting off excess, and let me see. We have ray P equals ray V. And so here, let's just modify this. So, we have an individual ray. Okay, so we have to define the initial position up here. So we're going to say, up here, let's do vector ray, I believe, is what we have here. So, well, let's go up, let's check. Ray array. Right, quit. Geometrical H, ray array. Here we are. It is an array with a ray in it. And we have a vec ray. Good. So let's make one of those. Geometrical.cpp. Let's go down to propagate, sweep, and let's change this to ray. 1 second. Am I sure I called it ray? Let's go over here. Vi geometrical.h, and let me see. If I just called it ray, that's kind of ambiguous, but that's okay. I just called it ray. So let's call it ray sweep ray with 3 E's. Yep, that's what I need to do. Ray defining, let me see, the ray to work with. Okay. That's okay. Yeah. Okay, so let's go down here. So we give the ray an initial position and an initial index. So we will define it at a particular position. So we'll say sweep ray dot x is going to be equal to, I think it should all be the same. So let me see. How do we define our initial ray set? Light gen. And what did I define it as? Vector position. Vector raise I position, raise I velocity. Oh, wait a minute. Vector, of course. So we started at 0, 0, and x. My bad. So let's go down here and let's define it as 0, 0, and x. So it's going to be ray.position.x. It's going to be equal to 0.0. Now we do y. And we're going to say sweep ray.position.y is going to be equal to, now, how are we going to put this? The initial one, and I just realized I have too many i's here. Let's change this to a j, and this to a j, and this to a j. Let me go up here real quick. How did I do that? 1 second, guys. This is a little disconcerting. Oh, I see what I did. Shoot. Let me change this to a J. Actually, do I use I in here anywhere? I do. Okay, I use it down there. But let's keep this one as an I then. And let's go and change the interior loop here to a J. I apologize. When I did this earlier today for the, because I changed the way this loop works, it kind of changed some things also on the inside here. 1 second. So we're going to change this to a J. Change this to a J. And let me see. I think this should be okay. Change this to a J. And this, of course, to a J. I think those are the only points where I needed I. Yes, so I think that should be okay. And we'll run it again. Actually, let's run it again right now with a different refractive index, just to kind of mess around with things. So, what else do we want to try? Let's try just, let's just try 1 over. No, there was one in particular that I thought was super cool. Let's see if we can figure that one out. Diff this one maybe? Yeah, let's try that one. Okay, let's go here. Let me go up here and define diff. Where are we? We'll define diff right here. It's going to be equal to... Oh, actually, no. We define it in here. Diff is going to be r divided by lens dot radius. Write this, go over here, right quit, and let's make that. Okay, good. So something broke. Let's go ahead and fix it. Geometrical 198. For size j equals 0. Expected primary for oh, of course you did. For now. J was not declared in this scope. This should fix it. No, it didn't. Okay, expected primary position for dot. If absolute value, let's go to 201. Ah. Hey, Zivo. Let's just go ahead and comment out this guy for now. And then we'll come back to it. Okay. So, we're just going to make it. It's going to break. Oh. Oh. I made a mistake. 287. Index equals index. Where was it? Here it is. Not that that really matters that much, but write this, go here, make. Okay. Now let's keep working on our new propagate function. And again, guys, any questions, let me know. So let's go ahead and DD here. And let me go down here and remove that. Okay, so what do we need to do? What we need to do is basically give these guys a position. And I see, Gustrin, what you're saying. Ray P is equal to that. We can do it that way too. Why not? Let's just do it that way. So let's go here. Ray P is going to be equal to vector of 0.0. And now we have to figure out what we're doing for y. So the y position should be equal to 0, starting at 0, plus I times 2 times radius. So it's going to be I times 2 times radius. So that's going to be sweeping down this way. And we're going to have to divide that by... divide it by number of frames minus over 50. So let's divide this by number of frames minus 50. And that should be right. Yep. Yes, thank you. Gothic Death Eater. You don't work as a marine biologist, do you? No, I do not. Why? By the way, thanks for coming back in, man. I haven't seen you in a while. Okay. So, Ray, P, Vector, 0, 0. This should work, I think. I don't know. I don't know what I'm doing. Okay. So now we have Sweep Ray. And basically, every time we see Ray down here, we just need to add a sweep before it. So let me go down, find all the rays. Here it is. And let's add a sweep. Good. Next one. Yep. Add one here. Next one here. Yep. There. Yep. Nope. Yep. Yep. Next. Oh. Undo that one. Next. Good. Yep. There we go. Yep. Set. Fantastic. Okay. So what do we need to do next? So this is us going through, and what are we doing? We are, you know, the fact that I and the other loop was screwed up makes OpenMP even worse. I don't think that it managed to complete a single iteration. Yeah, however, yeah, maybe you're right. Maybe if we try it again, it'll work. with the I and J's. Do you want to try it? We might try it tomorrow, since it's 6:50 today. So I guess we'll finish up this function tomorrow, and we'll go from there. Okay, so what's next? We have sweep ray previous index is equal to n over 2. Now here's the thing. At this point, guys, we have a sweep ray position, which is its current position, and we have a position before, which should be a temp position of some sort. So let's go through and let's do it. So here we're going to do ray here, and we want to do vector temp position, and we're going to say sweep ray is equal to this, and it's constantly updated through the loop. So I guess all we need to do is give this guy a static frame to work on. Yeah, so this should be okay. So let's see what happens. What I want to do then is animation.current frame. Yeah, okay, so this should work. So I want to do, where are we? Right here. We're going to say temp position is going to be equal to sweep ray dot position. Okay, now let's go down here. Sweep ray previous index equals n over 2. This should end the interior loop. And so down here, one second, we're going to have to add in a time step. So down here we're going to say animation.current frame plus equals 1. Okay. No. Let me change this. Let me do this a different way. I'm going to say draw frame plus plus. Let me go up here and create an int draw frame. Int draw frame. Good. Okay, so we're going to write this. We're going to go over here. We're going to take a look at Mirage. So let's see what we got here. Let's scroll down. Here's the light coming in. And this seems to just... Yeah, okay. My bad. This doesn't seem to be quite as cool as I thought it would be. I don't remember what this one's supposed to do. I just didn't let it run for long enough, I guess. But we'll see what happens. Okay, so I'm just gonna leave this up for now. Okay. So what's next? We have the temp ray position. Now we just need to draw the ray out. And this is just a matter of not necessarily animating the line, but using Cairo draw 2 to just draw the line on the particular frame. Yep, so let's do it. So we're gonna say is down here, Cairo line 2, and I think, if I'm not mistaken, all we have to do is this. Animation dot frame context of the following draw frame. Okay. Hey, Gregorian 2002, how are you? So we're gonna say draw frame initially starts out as 0 here. That was a 90. Okay. So we started out at 0. Now we go down here, we have animation frame context draw frame, and then we give it a place to go to. So where do we want it to go to? We want it to go to, we want it to go to a particular X position. So it needs to go to, wait. I think we need to give it starting positions and ending positions. Crap, I don't remember how this function works. Let's take a look. So vi optics visualization.cpp, Cairo draw 2. Sorry, Cairo line 2. Here we are. Frame animation. Oh, okay. So we just give it an X and Y to go to, and we assume that it's already at the appropriate position, which I guess is a fair assumption. So let's go here, and let's move it to the appropriate position, which is going to be Cairo move 2, and we want to do animation.frame context of draw frame, and then we want to move it to the appropriate position, which is going to be sweep ray dot position dot x and sweep ray dot position dot y. Just in time, or just in space, whatever. So now we're gonna do we need a temp p? We might not. We might be able to do this without a temporary position. That'd be super cool. So let's do sweep ray dot p dot x, and we're gonna do sweep ray dot p dot y, and a semicolon, and put these guys down onto the next line, just for the sake of readability. Good. Now let me go up here. I don't think we need temp p. I really don't. Let's go ahead and remove that. Move this up here. Let's go down to temp p. Okay, it's only in that propagate function. So let's go down here. And I think this should draw the line exactly as we want it to. So basically the idea... What'd you do, Frank? Basically the idea is that every one of these time steps we are drawing a line, and I think... How many lines of code are there? Oh, I don't know. Let me see. What, Frank? Was it not on Git or something like that? Let's do num set number. This one has 315 lines in it. Let's see. This guy has 112 lines in it. This guy has 102 lines in it. And this guy has 436 lines in it. So I'm going to say order of magnitude about 1,000 lines. Right, quit. Now we're going to do... But I mean, you could have put it on like Bitbucket or something, right? A closed source site. I can do clock dot. I don't have clock. But, oh, maybe I do. What if I do Yowert clock? Clock. Apparently it's a thing that I didn't know about. Count lines of code. Yeah, let's do it. 5. Oh, dang, Frank, I'm sorry. Do you not have it backed up anywhere? Can you not find it? So let me do clock dot. And it says C++ header. Oh, only 573. Not as bad as I thought. Any way to recover the .h files only? I don't know. I don't know, Frank. I'm really sorry, man. I know you've been working on that for like months. So let's go ahead and clear the terminal. Why not? Go into geometrical.cpp. Honestly, guys, I think the propagate sweep function is pretty much done. I can't think of anything else needs here. Propagate sweep. Okay, so... Oh, I see. So I was counting comments. If you discount comments, you're right. Yep. Okay. So what do we need to do? I can't think of what else we need to do here. We have the draw frames being added in. Everything else seems to be fine. I'm going to try it. I'm going to try it, and we're going to fail miserably. That's the story of my life. So we need lens, step size, max velocity, and animation. Honestly, I think... Well, let me just make it. Error, radius was not declared in the scope. Good. 196. Sweep ray, radius, 2 times radius. This is going to be lens dot radius. Right now I'm recovering all the files, but the names are mangled. Ugh. I'm just getting into source code at the age of 14. What are some tips on coding? Well, Gregorian 2002. The truth is, when it comes to programming, yeah, back up your source code. That's a very good one. Everyone kind of learns a little bit differently. Some people, they need a structured class in order to learn. Other people just kind of go at it, and they learn based on one thing or another. What I would say is get a book on whatever language you want to learn. Could be C++, could be Python, could be Java, I guess. I don't use Java that much, but it's quite popular with Android and people like that. And then just kind of go through it one step at a time. It's just a matter of learning little bits and pieces, learning how to do, loops, statements, just little things here and there, and then just get started working on a project. Just learn what you need for that project. That would be my opinion. I totally accidentally knocked a mug of full water over my Office MacBook Pro last week. Holy cow. Had an order of a 10-meter Ethernet cable as communication chip. Oh, man. Holy cow. I'm sorry, Matt. Everyone's having some sort of technical problems. Yesterday, I spent the entire day. Thanks, Slayer Darth. Oh, yeah, so you probably just get a good IDE or something like that. I don't know. I don't really have too many good... the trick is, or at least for me, just find a good project, try to work on it, and go from there. That's what I would say. Okay, so let's go down here. Let me go ahead and comment this out. And let's... Oh. Add in propagate sweep. Sweep. Okay, what do I want to do? I'm going to read in, not raise, just lens. 0.0001. Max velocity. And layer of 1. Okay. Write this, go over here, and let's make that. And let's see where it breaks. Didn't break. Okay, so if you can come up with a cool project, that's cool too. Yeah, that's true. If you want to go through the web dev route, I found it extremely easy to learn from. Oh, GitHub Pages. Yeah, that's another thing. I have a GitHub Pages account myself. So let's take a look at the image that we just made. I'm Mirage, and nothing's happening. Shoot, that's because I forgot to do Cairo stroke. So let me go and do that right now. Can't believe I forgot to stroke Cairo. Dagnabbit. That's what I get for putting all this stuff in additional functions. So Cairo line 2. Now let's do Cairo stroke. Cairo stroke. And we're going to stroke the context. So animation.frame context of draw frame. Good. Let's go there, right. Go over here, and let's make that. See what happens. Our school district has a robotics program as well as a website called code.org. Yeah, that's pretty cool. If you're interested in robotics and stuff, there's robotics that are incredibly cool. Anyway, I can recover the lost source code. How did you remove it, Frank? I know if you just did RM, that's kind of hard to get back from. But I know there are some tools that allow you to get back from it. In fact, I've done that before where I've accidentally deleted a whole bunch of source code and I've had to go back. You can probably just Google it. Oops. Okay. Man, where's BPAF? He used to always keep track of all the quotes. Okay, so let's see what this one looks like. Mirage. We have a line going the wrong way. 1 second, let me take a look here. Yeah, this line's totally going the wrong direction. Yep. Okay, so let me think how we're gonna fix this. We need to go through draw frame plus. Oh ho. I see a bit of a problem. I don't think an IDE is really necessary, is it? I guess if you're using Windows, otherwise find a simple text editor. It's fine for me on Ubuntu. I agree with you, Slayer Darth, because it honestly gives me a better idea. A better idea. I think compiling it with from scratch, kind of like that, not with an IDE, kind of gives me a better idea of what's happening underneath, which is incredibly useful. So what happened there was the line went down here when I wanted it to go down this way. So let's see. We are drawing at each frame all of the lines, but I've got a feeling that I'm somehow doing this incorrectly. Let me see. Cairo line 2. So each of these guys, if n1 is not equal to n2, that seems fine to me. So we're going to do Cairo line 2. Let me think. Cairo line 2, animation frame context draw frame. Sweep P ray X, sweep ray P Y. I mixed up the variable names there, but that's okay. So here's what I'm going to do, guys. I'm going to leave today off at a bit of a cliffhanger. Yeah, I mean, you're right. I do... I'm sorry, Gregorian. Everyone seems to be having technological problems. Yeah, I don't use an ID. No, I do not. So let me go ahead and write quit. So this is what I'm going to do, guys. I'm going to hold this off for today. We will get back to it in a little bit. Honestly, let's see. It's pretty much there. We just need to figure out that one bug that makes the line go this way instead of that way. It's probably just mixing up X and Y at some point. But that's okay. I'm going to go ahead and leave it at a bit of a cliffhanger for today. It's 7 o'clock in the morning, 7:05 in the morning, which is a little bit past the time I typically end my stream. So I will see you guys tomorrow for the next episode of Simulaos, where we basically work on visualizing different guys. We get the sweep function finished, and then we go from there. Hopefully everything will be good after fixing that sweep function. But outside of that, I don't see too much more to get done. So we'll take a day off after finishing this simulation up. We'll move on to the next one, which I don't have planned yet. So it might be more than a day. I don't know how long it's going to be off. We need to figure out what to do next, but that's okay. I think that's it. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simulaos, where we continue working on this system and getting it fixed up. And that's about it. So see you guys next time. Have a great day, guys, or a great time. Bye, guys.